So on to problem 17 of the MIT integration being qualifying exam 2014, which is the indefinite integral of 2 over 6 minus 11x plus 6x squared minus x cubed. Okay, so let's see how we may be able to solve this problem. Yeah. So we have 2 over 6 minus 11x plus 6x squared minus x cubed. Looking at the lowest degree here of 0, we have the multiples being right. So we can choose to substitute in positive 1, and we see 6 minus 11 plus 6. And what I'm trying to do here is, suppose I have a polynomial equals to 0 like that. If we substitute 1, we get 6 minus 11 plus 6 minus 1, and this equals to 0. So it makes sense for us to divide that polynomial by x minus 1. Sorry, 1 minus x. So that by 6 we have 6 minus 6x. This becomes negative 5x plus 6x squared minus cube minus 5x. This becomes minus 5x plus 5x squared, which becomes x squared minus x cubed. So minus x squared gives us, plus x squared gives us x squared minus x cubed, which is 0. So in other words, 6 minus 11x plus 6x squared minus x cubed equals to x minus 1. Sorry, the same as 1 minus x, 6 minus 5x plus x squared. Okay. So we have 6 minus 11x plus 6x squared minus x cubed being equal to 1 minus x, and we do have 6 minus 5x plus x squared, which is 1 minus x. Here we have 6 minus 3x minus 2x plus x squared. Which slowly becomes 1 minus x. Pull 3 out. 2 minus x. We pull x out. We have 2 minus x. Okay, so we have 1 minus x, 2 minus x, 3 minus x. Okay, so our fraction 2 over 6 minus 11x plus 6x squared minus 11 minus x cubed is equals to, say, 2 over 1 minus x minus x. So let's do some partial fraction decomposition. and see how that goes. So if 2 over 1 minus x, 2 minus x, 3 minus x equals to a over 1 minus x plus b over 2 minus x plus c over 3 minus x. That means if we go methodically and say, okay, we multiply across by 1 minus x, in that scenario, we do have 2 over 2 minus x, 3 minus x equals to a plus b 1 minus x over 2 minus x 3 minus x. And then we substitute in 1 in place of x. This goes to 0. This goes to 0. And so 2 minus 1 is 2 is 1. 3 minus 1 is 2. And so we have 2 over 2 being equal to a, meaning that a is positive 1. And if we repeat the same for 2 minus x, what will become is we have 2 over 2 minus 1 is 1. 1 minus 2 is negative 1. 3 minus 2 is positive 1. So we have negative 1 being equal to b, and therefore b will be equal to negative 2. For c, we have 2 over 3 minus 1 minus 3 is negative 2, and so we have negative 2 times negative 1, so it becomes positive 2 and equals to c, and so c equals to 1. Okay, and so we have our fraction 2 over 1 minus x, 2 minus x, 3 minus x being equal to 1 over 1 minus x is 2 over 2 minus x plus. So the integral of 2 over 6 minus 11x plus 6x squared minus x cubed is equals to the integral of 1 minus 1 minus x to 2 minus x which is equals to negative natural logarithm of 1 minus x 2 natural logarithm of 2 minus x minus natural logarithm of 3 minus x. Okay, so we can always combine these two here, so we get 2 natural logarithm of 2 minus x minus which is equals to 2 log 2 minus x using the rules of logarithm where we have log a log b equals to log ab. So using that, we have now combined that, and that means that 2 log 2 minus x minus log this is 3 minus 4x plus x squared plus c. There's plus c up here. So I think our final answer would be the big integral of 2 over 6 minus 11x plus 6x squared minus x cubed being equal to 2 log 2 minus x minus natural logarithm of 3 minus 4x plus x squared plus the integration constant. And that is our answer.